วัสดีค่ะ Hello everyone. In the previous chapter, we talked about the AIEI background, the power of AI collaboration, and the cases in many areas. In this episode, we will talk about the real use case of generative AI. Today, we are honored to meet with Associate Professor Dr. สรณะ นุชอนงค์ Faculty Member at School of Information Science and Technology or IST at วิทยาศิริเมธี Institute of Science and Technology or Vistec, which is one of the 9 members of AI Engineering Institute or AIEI. สวัสดีค่ะอาจารย์สวัสดีครับ Welcome to OPEN-TEC program under OPEN-TEC Technology Sharing Platform powered by TCC Technology Group ค่ะอาจารย์คะ Let's start with the benefit of Vistec as the AIEI member.
Yep. Thank you very much for this question. I think Vistec as a research institute, we place a high value on the development of new knowledge, right? And we think that in order for knowledge to be useful in society, it has to be applied to real world use cases, and we do this through different forms of partnerships with AI Engineering Institute. We think that engineering is something that bridges the gap between scientific knowledge and the real world practical usage. So we're hoping that through this collaboration we can scale up, we can make use of our findings to something that's useful in the real world.
Could you please share background of Vistec and if any collaboration in AI research project with other organizations?
Yeah. So Vistec is a research university, but we are funded by industrial leaders like the PTT Group and Siam Commercial Bank. So these are our major partners in collaborations. For example, we work closely with SCBX in order to make our knowledge useful to them. We basically like at this moment, all right, we're trying to come up with a way to meaningfully measure, to understand the behavior of AI systems through different kinds of benchmarking frameworks. I think one thing about AI in this current climate is that the ability, all right, kind of like outpace understanding. We think that like technology is extremely useful and it can be used in so many different ways, but without understanding benefits and risks associated with the technology, we might overestimate or underestimate the technology.
Yeah, I definitely agree with you that technology is useful, but we have to understand more, right? Any example of the real world use case of AI that you involve for a specific industry?
Yep. We work closely with legal experts in order to build a system that can assist people, just regular people, when they want to know more about their legal problems. So this is something that very early stage, all right, in the sense that we still don't know the capability of language models when answering complex questions like the Thai legal system.
Yes.
Yeah. So the first step into this whole development effort is to first create a measurement scheme so that we understand what the gap is and we can address problem. We can direct our efforts to the right places. So in this case, we came up with this thing called NitiBench, where we set of legal questions required the ability of an AI system to identify the law that's needed to answer the question. Just imagine when you talk to a lawyer, all right?
Yes.
You come up with a legal question. They don't give you the answer right away. They usually go for the law sections that's relevant to your case.
Yes.
And come up with a legal interpretation.
Yes.
Provide an analysis and answer. We still have no benchmark to measure the capability of any language model in the Thai context. So we came up with like the benchmark called NitiBench.
อาจารย์คะ could you please elaborate more about the NitiBench and to give like how importance of this kind of benchmark, because this is for benefit of the audience that may not be familiar with the legal stuff.
Let's go back to the example that I just gave you.
Okay.
Right? Imagine that you're asking a question, all right, to a lawyer. The first thing they do is to identify the relevant law. This for an AI system, all right, is called Retrieval. Yeah.
Oh, retrieve the data. Right?
Yeah. All right. Given a question, retrieve the relevant law sections.
Okay.
That's the first ability that we need to test. Yeah. Because if the system cannot identify the correct law to be applied to, then we are done. All right. Like, think of a lawyer. They're not proficient with the law they're operating with, and give you incorrect law to apply. All right, we done at that step. We don't need to think further. Yeah. When you have a wrong reference, then that's it. All right. That's the first thing that we need to test.
Yes.
Yeah. The second thing that we need to test is the ability to apply the relevant law to the case.
Yes.
Right? That's something that's also, it can go wrong in so many different ways.
Yes.
Yeah? For example, reasoning, all right, it can apply a wrong reasoning logic, and then it gives you a wrong answer.
Yes. Okay.
So for the whole pipeline, we need to test these two capabilities.
The ability in retrieving the data, and
the ability in
applying.
Yep, in application. Yep, that's right.
Oh, okay. That's not easy task.
Yeah, and the thing is, like, this is probably something that we need to do for any QA systems.
Yes.
Yeah, if you think about it, like legal compliance. Yeah, if you talk about the legal compliance effort in the PTT Group, all right, that also can be considered like a legal QA problem, in the sense that you need to identify the correct regulations,
yes.
right, and then interpret and apply that regulation to the case.
Okay, what are the biggest challenge you face when developing and deploying this AI, especially Thai LLMs?
You can test so much before deployment. All right. In the end, the real test is when you deploy the system. Right? So basically, dealing with unseen cases. All right, and how it has to be handled in real time, yeah? Or basically coming up with a pipeline that allows the unseen cases of today become test cases of tomorrow. All right, so it's about coming up with a scheme to allow continuous improvement. Working with users so that they can have the correct expectations about AI system. In a way, I think we are on the optimistic end of things in the sense that users kind of expect that if it can answer this sort of question, then the ability is going to be generalized to other things as well. But at the end of the day, an AI model is as smart as the data you give to it. Right? So how we work with users in order for them to give the relevant data to us that matches the expected behavior that they want from the system. This is also something that needs a lot of communication.
Okay, that's the challenging things. อาจารย์คะ could you please explain more about the unseen sample?
Yeah, this is a very complicated concept because if you want to test an AI system, most of the samples are going to be unseen. But talking about here is the extent to which the sample that you are testing is different from the seen samples. So basically, you might train an AI system from a given sample distribution. In this case, most systems can handle unseen samples within the distribution very well, but it will mostly fail in cases where the samples are obtained from somewhere that's far away. Right? Something that's so much different from training samples that the model has seen before. So that's where limitation lies, right?
Yes.
So if you define expected behavior to be something, you must make sure that you have training data to support it as well.
อาจารย์คะ What the future technology advancement are you most excited about, and how do you plan to leverage them?
There are a few things that I think we should pay attention to, right? In order to in order to leverage the technology. The first thing is that for the past few decades, we can see that there were problems that used to be challenges in AI, and now we have solved it through deep learning, in the sense that given that we have enough data, we can pretty much solve any pattern recognition problem. And what I mean by pattern recognition is that given input-output pairs, we can build a system that maps the input to output. Right? This is huge, all right? And it's quite amazing how this is the kind of thing that we can take for granted nowadays. So the question is, right, with pattern recognition being solved, what can we build on top of it in order to leverage this technology? One of the things that I see tremendous progress is the fact that we are moving beyond an agent that acts in one step. When you think about it, how AI progress has been so far, we built a system that reflects to an input, right? This is an input, and here's an output for you, and that's it. Think of system like OCR, just one step sort of thing. You see the character pattern, and you come up with a digital representation of it, or object recognition, right? Recognizing whether something is a car, a bike. This is the kind of thing where we need only one step of judgment. Now, okay, we can see that we can build a reinforcement learning system on top of this pattern recognition system. What this is going to allow us to do is to have an AI agent that can look multiple steps ahead, right? And reasoning is one of them, all right? That that we get from this. And I hope that with this advancement, it's gonna help us solve the unseen sample that we talked about earlier, right?
Yes.
When an AI model can reason, it can generalize things that it has learned better, right? So reasoning, multi-step thinking, these are things that I'm very excited about. Another thing is that we are moving away from an AI system where only one single model does the heavy lifting. We are moving towards some sort of like a modular approach, where we have different components interacting with each other, and so in a way, right, we are moving towards engineering, right, studying how different components interact with each other, how we design a pipeline that's going to give us the best output, right? So yeah, AI engineering is probably something that we, from the academic research perspective, it may not be that exciting, but in the real world, where we want to build a system that can scale, right, this is going to be something that really changes how we implement an AI system. The third one is about the democratization of automation. You can think of it this way. Before the chat interface that we get from large language models, the people who have access to automation, people who can program, right? Nowadays, people without any programming knowledge can reasonably build an automation pipeline, right? Through interaction with an LLM, right? Think of it this way, right? If you got a long email from someone and you don't want to read the whole thing, let's just assume, right? Or you want to extract key information,
Yes.
from the long email. So you can create like a structure, some kind, like maybe create a table. You can do that easily nowadays.
Yes.
Right? Without a line of code, right? So this kind of like automation where it's very, very personalized, right? Now everyone has access to it, and that's gonna has a huge implication of productivity and the engagement of users in developing an AI system as well. So basically, these are the three things that I think we should be looking at.
Oh, that's interesting. Okay, อาจารย์คะ what's the critical role of AI engineering in advancing both generative AI and agentic AI technologies?
Yeah, that's a good follow-up from the previous question as well. When we're moving towards modular system, right? The problem becomes more like more engineering-like, right? Because now engineering design becomes more critical, right? And another thing is that if you look at like 5 or 6 years ago, people don't talk about AI engineering, right? We just want to try things out, like and see how they work. I would say it's more like a curiosity-driven development. Yeah. So when you can apply the term engineering to a discipline, it's a sign of maturity. We have collected enough practices, right? Best practices in order to come up with a new engineering discipline. I think this is something that's gonna help us scale AI. All right, and if you look at other disciplines, all right, for example, chemical science and engineering, all right, the division of labor is pretty clear, all right. For chemical science, they try to come up with new understanding, but when they want to scale, they come to engineering. All right, so there is this interplay between science and engineering. Right, so this is going to be something that we see in AI, like for many years to come.
How the AI engineering can help solving the AI problem?
As I mentioned earlier, right, we are moving towards modular design when we try to solve an AI problem. And when you have multiple components interacting with each other, it implies a deliberate engineering design effort. Right? Let me give you an example. Large language models, or LLMs, are very, very bad at solving mathematical problems. All right. So if we treat this as an engineering problem, all right, we want to create an AI system that can reliably solve mathematical problems. Okay, how would you approach it? So yeah, we can think of it this way, right? LLMs are very, very good at languages.
Yes.
Yeah, they're very good at translation, and then there are existing mathematical solvers that we can use, all right? But the problem is that these systems do not understand natural language. So a practical engineering design to solving this problem, we can decompose this problem into two components. Yeah, the first one is language understanding. All right. The second one is the actual solving. Yeah. So if LLMs are good at languages, we can use it to translate the question in natural language to symbolic language that mathematical solvers can understand. So basically, like we can see a shift. A good engineering design goes a long way, all right, and it usually gives us a better payoff than trying to solve one problem with one single model.
So basically, this is how AI engineering solve the problem. And last but not least, any key message that you may like to leave for our audience?
I think we see a shift where the end user of AI is just an end user. All right. Now we see a shift where end user can help co-develop, right? Can help define the automation experience. So I believe that the development of AI technology in the future is gonna come with co-creation, right? Where we get active user engagements. One of the things that should be driven through co-creation is AI governance. Right? When you think about it, it requires people working in tech, in AI, to come up with a technology that complies with the policy and regulations, and it also requires policymakers to come up with something that makes sense as well, right? And user to understand the benefits and the risks of the technology. It also requires effort from people from academia like me to help come up with a with a system with an assessment scheme, right, to test the system. What I would like to propose is that we can use AI benchmarking like NitiBench as a middle ground for collaborations. Policymakers when they engage in benchmarking effort, their policies can be more grounded with what's actually measurable, right? Because basically we cannot enforce what we can't measure. And that's a principle, right? And for technology developers, you like the TCC group, you get a helping hand. You're not the one trying to prove that your system meets the compliance standard, right? You get help from policymakers in terms of assessment scheme, benchmarking scheme, and people like me, right, who say that okay, if you want to measure these properties, these are the ways we can approach it, right? And users can contribute the data or can help define the expected behavior. So it's going to be a very exciting time where we come together and help shape the future of AI.
So that's great for the future collaboration that many parties can come and help in this area, right? Thank you so much, ค่ะอาจารย์ for sharing your insight today, and it has been a valuable conversation. And for the audience interested in learning more about the institute and the program of AIEI, you may visit cmkl.ac.th/AIEI. Thanks to all, and this has been AIEI mini series. สวัสดีค่ะ
So these are